This lesson is all about Pythagorean Theorem. Now the textbook gives you this definition: the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Once you see the formula, it's a lot more clear than that. But one very important thing to remember is this only works for right triangles. It will not work for obtuse triangles. It will not work for acute triangles. Only for right triangles. So before we get any further, let's look at some of the terminology you need to know for this. The two terms you're going to need to know for our right triangle are legs and hypotenuse. Now the hypotenuse is the side opposite the right angle in a right triangle. So here's our right angle, there's the hypotenuse. And then the legs are just the two sides of the right triangle that form the right angle. Again, here's the right angle, leg, leg. Now for our formula, one leg will be given the variable a, the other leg will be given the variable b. Which leg you choose for which variable really makes no difference because it's going to involve addition, and addition is commutative. Hypotenuse will always be c. So now let's take a look at the formula itself. Here's the formula: a squared plus b squared equals c squared. One of the most famous, or maybe one of the most infamous, depending on your viewpoint, formulas in math. To implement the formula is quite simple because you're doing the same procedure each and every time. So let's take a look at that. Here we have a right triangle, not drawn to scale, but that's okay. One leg is 9 feet, the other leg is 12 feet, and we're looking for the hypotenuse. So the first thing we're going to do is place those values, the values for the legs, in our formula, and of course we're looking for the hypotenuse here. Here I have gone ahead and squared 9 to get 81 and squared 12 to get 144. I did that first because order of operations dictates that we do exponents. And then I've added them together to get 225. Now, in order to simplify this, I have to use the inverse operation of squaring, which is taking the square root. So when you take the square root of c squared, you simply get c. The square root of 225, that happens to be a perfect square, so our value here is 15. So c equals 15. Let's take a look at one where they don't give us one of the legs. We're still going to follow the same procedure. We go ahead and fill in the information into our formula: a squared plus b squared equals c squared. I chose to use a squared here instead of b squared for my variable for no particular reason. Really, you could put 12 over here where a is and then use b squared because, again, addition is commutative, so it really makes no difference. But I can only do that for the two legs. I can't do that for the hypotenuse. The hypotenuse has to be by itself on the other side of the equation. So here I've gone and squared the numbers. And in order to get a by itself, I have to subtract 144 from both sides. That'll give me a value of a squared equals 340. And just like the previous problem, I have to take the square root of a squared and the square root of 340 in order to find out what the value of a is. So a equals approximately 18.4. If you took the square root of 340 on a calculator, it's going to be 18.4 something something something. Traditionally, you just round it off to the nearest tenth. Now let's look at a rule that is related to the Pythagorean theorem, and of course you can see it's called the converse of Pythagorean theorem. It simply states if the sides of a triangle have lengths a, b, and c units such that c squared equals a squared plus b squared, then the triangle is a right triangle. More simply put, if we have two legs and a hypotenuse, we throw those numbers into our Pythagorean theorem and they equal each other, then it's a right triangle. So let's go ahead and take some numbers and throw it into a formula for our Pythagorean theorem, which is down here. Here we've got 13 squared equals 5 squared plus 12 squared. I've gone ahead and squared each of the numbers, added 25 and 144 together, and as you can see, the two values equal each other. C squared equals A squared plus B squared. That means this is a right triangle. Using a different set of numbers, we have 14 squared equals 3 squared plus 11 squared. I went ahead and squared the numbers here. And adding up 9 plus 121, I get 130, and you can see that this does not equal each other. So 14 squared does not equal 3 squared plus 11 squared. So this would not be a right triangle. It's probably some type of triangle, but it's not a right triangle. So that's the converse of the Pythagorean theorem. So a few things to remember. There's essentially 3 steps for the Pythagorean theorem. First, you have to square the numbers you have. Then you add or subtract based on what side you're looking for. And finally, you take the square root and you round it to the nearest tenth. And the Pythagorean theorem only works for right triangles. It will not work for obtuse triangles or acute triangles, only for rights.